everyone, welcome to Unit 2.12. It's Momentum Part 2. Yes, Part 2. Oh god, let's get going. Momentum. Here is something interesting. When you fire a gun, the bullet flies out, right? But the gun also gets blown away if you don't hold it tightly. Why? It's because of Newton's third law. But is there a way to tell how much kickback there is just from the momentum of the bullet? Yes, because momentum to the left equals momentum to the right. This means that both the bullet and the gun have the same momentum. Example, if the gun has a mass of 50 grams and the bullet has a mass of 5 grams, the velocity of the bullet is 10 meters a second. What is the moment of the gun? What is the momentum of the gun? The momentum of the bullet is 5 grams times 10 meters a second, so it's 50 meters a second. So therefore, the momentum of the gun is also 50 grams meters a second. Yeah, that's the momentum of the gun. It's a little bit hard to comprehend. It's just Newton's third law working in action. Whenever you push something, it pushes you back. Whenever you fire a gun, the gun also gets fired back. It's kind of weird actually. Okay, conservation of momentum. The law of conservation of momentum states that when two or more objects act on each other, the total momentum remains constant, provided no external forces are acting. This is just like the gun example before, but this also applies to collisions. So, for example, a car is traveling at it has a momentum of 10, for example, and then another car is traveling in the opposite direction with a momentum of 11. So they crash into each other, and so their total is actually 1 momentum, and so their momentum afterwards is 1. That's their momentum afterwards, and from that you can derive their force, their speed, their whatever. Alright. If a 4 kg ball travels at a velocity of positive 2 meters a second, and another 1 kg ball is traveling at a velocity of 8 meters a second, collide, what will be their momentum of the collision? First, we have to find their momentum. Their momentum is 4 kg times 2 and 1 kg times 8. So both of it you get 8 meters a second, but it's positive and negative. So they have the velocity, we first have to find the momentum, mass times velocity, and they have a velocity of positive 8 kg meters a second and negative 8 kg meters a second. We add their momentum to get 0 kg meters a second. So after the collision, the momentum will stay the same. So that means that the momentum will become 0 kg, and that means that their speed is 0, and that means that both of them stopped. So yeah, using this example, you can think of, again, like you throw a balloon at another balloon, and so their momentum, both of their momentums are equal, so you add them together, and then it'll become 0. So if their momentum is the same on either side and they're opposites, and they clash together, it will become 0. It's just like their balance forces that we talked about. Equilibrium, and the object will act as if there is no force acting upon it. Alright, I'm done. That's it. There's like 30 seconds left to spare, so I'm gonna spend it on ranting about the school system. Why? It's on marks, right? It's our school marks. Why do you have to do screencast? Why can't we just be judged as a person? Well, I guess maybe the teacher might have a bias against us. But Mr. Arif's a cool guy. I don't think he has any bias against anyone. He's a cool guy. Alright, anyways, that's it. 5 minutes. Thank you very much. I'm done.